All right, so this is section 5.3, the graphs of inverse functions. And I went ahead and wrote the notes out so you guys can go ahead and copy those instead of watching me have to write them out. You can pause it and write them out as you need to, and I'll walk through them a little bit here just so you can see what's going on. All right, so in order for f to have an inverse that's also a function, f must be 1 to 1, in other words, no repeated y values. Well, what that means is that for the original function f to be a function, it had to pass the vertical line test. And remember what that means. The vertical line test, what you're doing is you're literally going through and you're checking and you're seeing, do I have more than one y value for that x value? So that vertical line, it is registering an x. And what you're doing is you slide that line across. As you slide that line across, you're actually looking and seeing it's representing certain values as you go, and you're looking at, do I have more than one y value for that given x value? And in this case, you don't. Now, when we're looking for the other one, when we're looking for a horizontal line test, so that's the vertical line test is a test for it to be a function. If we rotate this around, now that is not representing a y value anymore, or sorry, an x value anymore. It's now representing a y value, and you're looking for this, any given y value, do I have more than one x value? Now, if you scroll on over here, you see for that x value, or sorry, for that y value, you have this x value and this x value. So that is not 1 to 1. And if it's not 1 to 1, that means, the easiest way to remember it, 1 to 1 means for every x there is one y and only one y, and for every y there is only one x. It means both of them. For a function, for just the regular function test, all you're doing is you're saying for this x value, is there only one y value? And then when you check the horizontal line test, you're checking, what you're really checking there is if it passed the vertical line test. When you do the horizontal line test, you're checking, will this function, will its inverse also be a function? So a function can be 1 to 1 on a restricted interval of the domain. What that means is that you can actually take out, you can limit yourself to what part of that thing you're going to look at. For instance, if you cut this down and only looked from A to B, from here to there, that thing's going to pass the vertical line test, it's going to pass the horizontal line test, it's going to be 1 to 1. Therefore, not only is it a function, f, but its inverse will also be a function. So f is 1 to 1 on the open interval from A to B, but it is not 1 to 1 for all real numbers. And there's going to be situations that we're going to look at in the not too distant future where this becomes absolutely a must, that we limit that domain that we're looking at for the function so that its inverse is also a function. Now remember, when we're talking about inverses, what's happening? The x and the y are changing places. Well, that means that what was the domain now becomes the range of the inverse, and the same thing in the other direction as well. So the domain of f is the range of f inverse, and the range of f is the domain of f inverse. X's and y's change positions in the in the function and its inverse. All right, the function h gives the temperature of a town, h of t, in Fahrenheit and degrees Fahrenheit, t days into the calendar year. Is h a one-to-one function? How do you know? Well, it all depends on how you're talking about, how you're defining t. If t is integers, yeah, it could probably be 1, but it's not. T, you could have t days into it, you could have 17.375. So it's going to be 17 days in and 0.375 through that day. So in that case, remember, temperatures are going to go up and they're going to come down. They're going to go up and they're going to come down, and they're going to go up during the day. They're going to come down at night. So that means what's going to happen? It means that you're going to have multiple times during the day, maybe not more than 2, but it could be, but definitely 2, most of the time, where 2 times during the day, most of the time where that temperature is going to be exactly the same. So is h a one-to-one function? No. There will most likely be multiple days where the temperature will be the same value at different times during the day. Now, follow what we did here. Remember, what is h of t? That is our y value, and t is our x value. So we're saying that we're going to have an output value multiple times for a value of x. So we're going to have more than one y for a given x value. And if we have more than one given y for an x value, then what do we know? We know that it's not a function. If it's not a function, it can't be one-to-one. All right, explain what this tells you about whether or not h inverse is a function. Well, if we have multiple days where the temperature will be the same, remember, that means that we're going to have more than one x for a given y. If we have more than one x for a given y, that means when you do the inverse, there's more than one y for a given x, and therefore that thing's not going to be a function. So since there are more than one day, since there is more than one day that a certain temperature occurs with the inverse, h inverse, we would have identical outputs for given inputs, since range of h becomes the domain of H inverse. Therefore, not a function. So since we had multiple days where the temperature would be the same, that means when we come down here to H inverse, there's going to be multiple days where we're for our given input temperature. Remember, we're going backwards with our inverse. So H is going to take the T value and give us a Y value. Well, the inverse is going to do the opposite. It's going to take a temperature, and it's going to give us the number of days that we have in it, the number of whatever days that occurred. So that's where we would have more than one day to a given temp. That would make it not a function. All right, so number 2 says sketch the graph of f of x equals x minus 3 quantity squared is the inverse of f of function. Support your answer with information from the graph. If not, how could you restrict the domain of f so that the inverse is a function? All right, so first things first, let's graph this thing. So that's going to be a shift right of 3 units. So 1, 2, 3. There is no vertical shift, so from right there, that's the vertex of my parabola. So is the inverse of f a function? Well, remember, for the inverse of f to be a function, it's got to pass not only the vertical line test, which this would pass, but it has to pass the horizontal line test as well. So the inverse of this would not be a function. The inverse of f would not be a function, since f fails the horizontal line test. And is not 1-to-1. All right, and your support for the graph would be something like if y equals 3, we're going to have a value there and there. So it would have two x values that would give me the same y value, or two x values from one y value on the inverse. All right, so it's not. So how could you restrict the domain of f so that the inverse is a function? Well, what we could do is we could literally go in here and we can split this thing down the middle because it's symmetric. And if it's symmetric, that means that for this point, I've got that point, for that point, I've got that point, for that point, I got that point, and you've got points on both sides. That's what's making this thing not 1-to-1. So if we take and we get rid of this, or if we got rid of that, if we only took one side of the parabola, it would still be it would actually be 1-to-1. So limited domains are restricted domains. That would, can't spell, can't write, make f inverse a function, or we could go from -infinity all the way up to 3. and we could even include 3. And that's going to be the part I'm marked out over here, so that would all be part of that. That would be 1 to 1 if we were just looking at this part. Or we could go from 3 to positive infinity. Either one of those restricted domains are going to make this a 1-to-1 function. But if it's an unrestricted domain for all reals, we noticed that we didn't, it was not, the function's inverse was not a function. All right, so find the inverse of y equals the square root of x minus 4, state its domain and range. All right, so remember, way back when you did the inverse of linear functions, the easiest, quickest way to do this is to first, if this would have been in function notation, write y in for f of x, then swap the x and the y. So x equals the square root of y minus 4. Then all you're going to do is you're going to solve for y. So first things first, I'm going to square both sides. So you get x squared equals y minus 4. And then I'm going to add 4 to both sides, so that I've got y all by itself. So the inverse, y equals x squared plus 4. So that is, well, let's rename this thing f of x. So that is f inverse of x. Let me write it correctly. Equals x squared plus 4. Now, the domain and range, that is where we're going to run into problems, because what do we know about square root? If we were to graph this thing, x squared minus 4 means we're going to shift to the right 4. 1, 2, 3, 4. And then our square root's going to look like that. Now, if we graph this, x squared plus 4, we're going to go up 4, 1, 2, 3, 4, and according to that, we've got a parabola, except for the fact that that is not really the reflection of that. We only have part of that we do. Well, here's the thing. Remember, if you know the domain of one and the range of one, then you know the domain and the range of the other one, because all they do is they swap. So look at this one, and what is the domain and what is the range of the original function. So this is of the original. The domain is going to be from 4 inclusive, including the value 4, and it's going to go off to infinity. The range, remember, is the y values, so that's going to start at 0 and go up to infinity. And once again, we can include the 0. So now, what does that mean when we go to do the domain and range of the other one? They swap places. Remember, they swap places. So that means that the inverse has a domain of 0 to infinity. And the range is the domain of the original, so it's going to go from 4 to infinity. Easy breezy, lemon squeezy. So the domain of 1 is the range of its inverse. The range of the original is the domain of its inverse.